All right, guys, so I promised you some homework help. I'm going to do a few problems off of each homework, 3 or 4, maybe 5 if I feel saucy. So this could help you out. Maybe some of them you're not sure what the answer is. This can give it to you. Plus, I mean, this gives you a few free points on the homework, okay? So I want to start off by looking at number 9. It looks pretty complicated, but it's not that bad if we split it up and take it piece by piece. So I'm going to take out my numbers, 32, and divide it by 20. I'm going to take out my a's. That's a squared over a. I'm going to take out my b's, b over b, and then my c's, c cubed over c. So now it's split up into 4 problems that are not near as bad as the whole problem together. So first I do the numbers. I can simplify that fraction. 32 over 20 simplifies to 8 over 5. I'm going to extend my division line there so that I can put a's, b's, and c's. Next, I have a squared over a to the first. The numerator has the bigger exponent, so by a goes the numerator. 2 minus 1, the exponents, gives me 1, so a to the first. B over b is a number divided by itself. Those cancel out and give me 1, so they're really not important to me anymore. Now I have c cubed over c. The numerator's exponent is larger, so the c goes in the numerator. And c cubed divided by c would give me 3 minus 1, which gives me c squared. So 8ac squared divided by 5. Let's look at, I think number 13 was giving some people some trouble, so let's look here. Now the problem with this one is that I have to do the outside exponents first. When you raise exponents to exponents, you multiply. So on the top, I have 5 cubed and a to the 2 times 3 over 5 squared a to the third times 2. Now we can clean that up a little bit. 5 cubed, 5 times 5 times 5 is 125. And I have a to the 2 times 3 is a to the 6th over 5 squared is 25. A to the 3 times 2 is again a to the 6th. Now I can simplify. I take my numbers first. 125 divided by 25 is 5. Now I go to my variables. A to the 6th divided by a to the 6th cancels out. My answer is 5. So go piece by piece. Bring those outside exponents in before you try to cancel anything out. Number 14, just really quick. Really, this negative a in parentheses is a lot like saying we have x to the 7th over x to the 4th. If we did it that way, the top one has a bigger exponent, so my x belongs in the numerator. 7 minus 4 is 3. But x isn't x is negative a to the third. So hopefully that one helps you out a little bit too. The rest on here is review, guys. I'm going to do number 16 because maybe it's a little harder than the rest because it's got a fraction in there. The first thing I want to do is subtract 5 from both sides. My goal is to solve for x, so I need it by itself. That leaves me 2/3 x equals 11 minus 5 is 6. Now to get rid of fractions, you multiply both sides by the denominator, which is 3. It cancels out the denominator and leaves me 2x. 6 times 3 is 18. I divide both sides by 2, and you should get x equals 9. So hopefully that helps. Now number 18 is similar, but what I would suggest is multiplying every piece by that denominator, and then it will be a fairly easy problem. So hopefully that helps you out a little bit on 11.1. Let's go over to 11.2. Now we have some negative exponent things going on. There's a few of these that have confused a few people, so I am going to do those. I'd like to start off with number 2, just because I've seen a lot of people get it wrong. I have in parentheses negative 3 to the negative 1. Now I need to remember that is actually a numerator. Since it's to a negative exponent, that does not belong in the numerator. I need to move it down to the denominator. So now I'm going to have 1 over in parentheses. It's still negative 3. But now it's to the 1. When you move negative exponents to the opposite place, the exponents turn positive instead. The numbers, negative or positive, will not change. There's your answer. okay? Number 5's giving some people some trouble, but again, remember, that's a numerator. I have two values with negative exponents. I'm going to move them down to the denominator. So now I have 1 over 2 squared times 2 to the third. Now I can clean that up. That's 1 over 2 squared is 4. 2 cubed is 8, which is 1 over 32. So fix numbers with exponents if you can. On number 8, just remember that anything to the 0 is 1. So it basically takes that part out of the problem. Number 10 is a good one. It has 2y to the negative 3, and that's really a numerator. The 2 is not attached to the thing with the negative exponent, so I'm going to leave the 2 on top and move the y to the third to the bottom, okay? Excuse me, sorry. Number 12, here's a quick one. This is really a numerator, and y to the negative 3 has to be moved. The x squared stays. The y to the negative 3 moves and turns into y to the positive 3. Number 14. Number 14 has some negative exponents trapped by another negative exponent. So first, I need to move everything to fix this one. It's a numerator, so I move it all to the denominator. 6x to the negative 2, y to the third, cubed. Now, I need to fix everything by cubing everything on the denominator. I have 1 over 6 cubed, x to the negative 2 times that 3, because we're multiplying exponents, and y to the 3 times 3. That gives me 1 over 6 times 6 is 36. (36) times 6 is 216. That's x to the negative 6, y to the 9. Now all you need to do is move your x to the negative 6 to the numerator, and you've got your answer. Now some of these look really bad, but they're not really as bad as they'd seem. The thing on number 17, you just need to move your exponent with your negative exponent to the other side. On number 21, just remember that 2 is not connected to the x to the negative 2, so just move that. And on number 20, it's similar to the one we just did. You have to square all of this stuff before you move your negative exponents. So don't even move the numerator stuff until you've squared everything in those parentheses. Let's go to the third one. So homework 11.3. Now I'm going to do 1 or 2 from the first page, and then we'll go from there. I think a good one to do, let's do number 10. Now I can rewrite that. P or PQ cubed minus P cubed Q divided by PQ is actually written like this. Now my suggestion was that you rewrite it as 2 separate problems. I have PQ cubed over PQ minus P cubed Q over PQ. So start with your P's. Over here, I have P divided by P. Those cancel. I have Q cubed over Q. 3 minus 1 is 2, so I have Q squared minus. I have P cubed over P, so I subtract the exponents, and I get P squared, and the Q's cancel. Now, if we look at number 12, just remember to rewrite it. And I'm going to rewrite it like this. I'm going to go ahead and split them up. It's 30p to the 4th q divided by 5, p squared q. Negative 45 and that stuff divided by 5, p squared q. And then 15 divided by 5, p squared q. Remember to do your numbers, then move to your p's and then your q's. There's no reason to miss the numbers on that one at all. Let's go and do another one. Let's look at number 13. All of them on this page are the ones that use the boxes. In the top left box, I put the first term of the numerator, p squared. And in the bottom right box, I put the last term of the numerator, plus 8. The divisor I put on the top as p and plus 4. So what you need to do is find out what goes here. Whatever is here times p gives me p squared. The only thing times p that gives me p squared is p. So I'm going to go ahead and distribute. P times 4 gives me 4p. Now I'm going to move down to the bottom. I know this piece is going to have to equal 8 when I multiply something by this 4. Well, what times 4 is 8? It would be plus 2. Now I'm going to go ahead and distribute that. P plus times 2 is 2p. Now I'm going to check. If these two add up to my middle term, it's right. 2p plus 4p is 6p. So our answer is this, p plus 2. Now, none of the rest of the examples are any harder than that, so make sure you do the same thing. I don't expect you to get everyone perfectly right, but you have to set them up or you're never going to get it. Now, the last one I'm going to do is number 20. It's a division problem. It's really over this. But I don't want to write my numerator in that order. I want to go from biggest exponent to smallest. So I have 2b squared plus 16b plus 49. And I'm dividing that by 2b plus 4. Now I need to find out what times 2b would equal 2b squared. Well, I already have the 2b, so the only thing I have to multiply it by is a b. And I'm going to put it in this column because that's where my just b's are lining up. Now let's do our multiplication. B times 2b is 2b squared. B times 4 is 4b. But we are subtracting those. So it's 2b squared minus 2b squared. It cancels, which is what we want. I have 16b minus 4b, which gives me plus 12b, and I'm going to pull down my 49. Now I do the same thing over. What times 2b would give me 12b? Well, that would be positive 6. 6 times 2b is 12b. 6 times 4 is plus 24. Now I am subtracting. 12b minus 12b cancels and leaves me 0. 49 minus 24 leaves me with plus 25. That is my remainder. So my answer is b plus 6 plus my remainder divided by my divisor. So guys, I know that's a lot of work. You've got to try. I mean, I say that all the time in class, but if you don't try, you're never going to get it. You should have these homework problems done on your homework. If you don't, that means you were being pretty lazy. Hopefully, if you're watching this, you at least wrote it down. If you have any more questions, just let me know.